Hi everyone, my name is Jakub Szymaszek. I'm a program manager and data group at Microsoft. And I'm here today to introduce you to Always Encrypted, a new security capability in SQL Server 2016. So Always Encrypted is an industry-first technology that ensures the data that is stored in a database remains encrypted at all times, even during SQL Server query processing. As a result, Always Encrypted provides separation between those who own the data and therefore should have access to the data, and those who manage the data and should have no access. Your applications and only your applications and users with access to encryption keys can access data in plain text. Others, including database administrators and other high privilege but unauthorized users, cannot view plain text data. By doing that, Always Encrypted provides the unparalleled level of protection against data breaches involving the theft of sensitive information, such as credit card numbers, government or national identification numbers, and other personally identifiable information. In addition to that, Always Encrypted gives organization more flexibility regarding where they can store or host databases containing sensitive information and who can manage those databases. For example, in certain industries, such as finance, there are compliance regulations that often mandate that unencrypted sensitive data cannot leave a certain country or region, and it can only be managed by IT personnel with high security clearance residing in that country or region. By removing Always Encrypted database from the attack surface area, Always Encrypted enables an organization to consolidate database hosting and to more efficiently utilize the IT personnel, for example, to let a DB in one location to manage databases in other locations. For the same reasons, organizations in highly regulated industries or customers who simply seek additional protection against data breaches, additional protection for their sensitive information, can now confidently store their data in the cloud and to take advantage of Azure SQL Database or SQL Server in virtual machines. So let me explain how Always Encrypted works. Always Encrypted is a client-side encryption technology in which a SQL Server client driver plays the key role. The driver encrypts the data the application sends in its queries to the database and then sends encrypted data to SQL Server. Now, when the client application retrieves the encrypted data from the database, the driver transparently decrypts it, returning plain text to the client app. Consequently, SQL Server never sees sensitive information in plain text. The server doesn't have access to the keys either. The keys, in fact, are managed entirely on the client side. A key can be stored in multiple locations. There are multiple options for Always Encrypted supports regarding storing the keys. The key can be stored in Windows Certificates or Azure Key Vault or special hardware devices named hardware security modules. Despite the fact that SQL Server never has access to plain text sensitive information or the corresponding encryption keys, SQL Server can query the data and can perform certain computations on encrypted data, namely equality comparison in equality joins, exact match searches, or group by operations. Let me now demonstrate how Always Encrypted works end-to-end. For this demo, I'm going to use a very simple web application that is a healthcare management system that manages information about patients, including their social security numbers, names, addresses, and so on. So now let me switch to SQL Server Management Studio and show you the database that feeds this application. So the database contains the patients table with the same information you just saw in the web form. And as you can see, all the information is visible in plain text. So anybody with the select permission on that table can read the data and can access this sensitive information, including patient's social security number. So this is the problem that we want to fix. We want to enable always encrypted in this database to ensure that only application can access data in the clear, and other users, including database administrators, cannot see plain text data. So now there are multiple ways to enable always encrypted in the database. I'm going to demonstrate to you the easiest method, which is by using the always encrypted wizard. So to start the wizard, I right-click on the patients table and I select the encrypt columns. That opens the wizard, and in the first page I can learn what always encrypted is about. I will proceed to the next step, which is the column selection page. In this page, I'm going to select columns that I want to encrypt, columns that contain sensitive information I want to protect. I'm going to select SSN and birth date. And for each column, there are two encryption-related properties that I need to configure: encryption type and column encryption key. For the encryption type, I have two choices: randomized encryption and deterministic encryption. Randomized encryption algorithm produces a different ciphertext value for a given plaintext value. Therefore, randomized encryption is more secure, but it prevents any operations on encrypted data. On the other hand, deterministic encryption always produces the same ciphertext value for the given plaintext value, and therefore it enables equality comparison on encrypted data in operations such as exact match searches, equality joins, or group by operations. There is, however, a slight security concern related to deterministic encryption, namely because, again, each plaintext value always maps to the same ciphertext value. An attacker can potentially examine ciphertext patterns and guess the underlying plaintext values, especially if a data set, a set of values contained in the column is small. For example, columns contains gender information about male and female. So that's something that you need to keep in mind and be careful about. Now, for my SSN column, I'm going to select the deterministic encryption because I want to be able to look up patients by their social security numbers. And I'm going to set the encryption type for the birth date column to randomized because I don't need any SQL queryability functionality for that column. The next step is setting up the column encryption key. Let me explain that the column encryption key is a key that encrypts data in a given column. I'm going to use the same column encryption key for both columns, and I will actually make the wizard to generate that key for me. Hence, that name that you can see here, CK Auto 1, which implies this is going to be an auto-generated column encryption key. Let me proceed to the next step. Here I need to configure a column master key. Okay, so in Always Encrypted, we have two types of keys. We have a column encryption key, which we introduced in the previous step of the wizard. A column encryption key is used to protect, encrypt data in a column. A column master key, on the other hand, encrypts, protects a column encryption key. Okay. In this case, I'm also going to use an auto-generated column master key, which will be a certificate, it's self-signed certificate put in a Windows certificate store. Okay, I will proceed to the next step, in which I'm being asked to if I want to proceed with encryption or generate a PowerShell script, which then I can use later on to encrypt my columns. I will choose to proceed encryption during the execution of the wizard. And here I'm presented with the list of steps the wizard will do for me. First, the wizard will generate a self-signed certificate and will put it in a Windows certificate store on the machine where SSMS is running. And the master key will be known to the database as CMK Auto 1. Subsequently, the wizard will generate a column encryption key named CK Auto 1. And then the wizard will encrypt the both columns that I selected, SSN and birth date. So let me proceed with encryption. What's happening now is the wizard downloads the data from the patient's table, encrypts it, and uploads it back. And in that process, the schema of the patient's table is changed. So now let's explore the changes that the wizard has done. Let's start with rerunning this select statement, and let's see what has changed. So you will notice that now the values inside the SSN and birth date columns are var binary encrypted blobs. So the wizard has encrypted the values that were stored in that table in these two columns. Now let me show you the schema of the patient's table and see what always encrypted wizard did to it. Okay. So let me script the schema. Okay. So now we can see that the wizard has added the encrypted with clause for the two columns that I selected in the wizard, SSN and birth date. The encrypted with clause has three parameters. The name of the column encryption key protecting data in the column, the type of encryption, deterministic or randomized, and the name of the encryption algorithm. Now, we haven't discussed the algorithm before, but let me just briefly explain. Always Encrypted currently support just one encryption algorithm, which is AES 256. Okay. So now let's continue this journey through the changes that the wizard has made in the database. And now I'm going to show you what SQL Server knows about the encryption keys that the wizard generated. So I'm going to start with scripting the metadata that SQL Server stores about a column encryption key. Here you can see that the server knows the encrypted value of the encryption key and how this value was produced, meaning which algorithm, in this case RSA OAP, and which column master key were used to generate this encrypted blob. Now, let's do the same exercise for the column master key. So SQL Server knows that in this particular database, a column master key is a certificate stored in the Windows certificate store, and here is a thumbprint of that certificate. It's important to emphasize that in neither case, SQL Server knows the actual plaintext value of the key. Okay. So now let's go back to our application and see how enabling encryption in the database impacted it. So what I'm going to do, I'm going to refresh that form that shows patient information. As you can see, the form is at the moment broken, and the reason for that is this application expects plaintext values, which are character strings for SSN and dates for birth date. Instead, it receives binary encrypted blobs. So we need to fix the application. So let me do that. And this is the key part, as because you will see that actually to enable always encrypted in this web application is a very simple operation that just requires me to add a new connection string keyword. Let me find the right place for it. Which is named column encryption setting, and set its value to enabled. And that turns the always encrypted feature on in the client driver, which is, in this case is ADO.NET, that this application uses. So let me save this change, and let me go back to the web application and one more time refresh the web form showing the patient data. Okay. Now we again can see the data in plain text. So let me explain very briefly what is happening here. This application is able to decrypt information retrieved from the database, including social security number and birth date, because it has access to that certificate that we produce in the wizard. It's basically running on the same machine where the certificate was generated and stored in Windows Certificate Store. And then it is able to decrypt a column encryption key and subsequently decipher the sensitive information and show it in the clear as expected. Now, I'd like to point you to a few additional resources about this exciting feature. You can download SQL Server 2016 to try it for yourself, and that's what I really would like to encourage you to do. This is a really exciting technology. We've been already getting fantastic feedback from a few customers, and if you have any questions or comments and feedback, we would love to hear from you again. Thanks again for watching this video.